In section 3.3, we're going to look at solving linear inequalities in one variable and systems of linear inequalities. The first part, part A, just deals with linear inequalities in one variable, so one inequality at a time. Okay. So the first piece that we have here, we're just reviewing the symbols, the less than or equal to symbol, and the greater than and the greater than or equal to symbol. The or equal to part is the bar underneath the inequality symbol. Okay. And we can describe each inequality statement with the inequality, a graph, and interval notation. So for the x is less than 5 case, we're looking at all the numbers below 5, so our arrow is pointing off towards the left, and the 5 is open circle. Open signifies that the 5 is not itself included because there's no equal bar. If it was x is less than or equal to 5, same. However, the circle on that 5 is now closed to signal that x can equal to 5. It doesn't have to be strictly less. So strictly less, open circle, less than or equal to, closed circle. So I noticed that on the graph. In the interval, I would notice the open interval with the parentheses, and I would notice the closed interval with the bracket. The same is true of the greater than and the greater than or equal to. The greater than, the arrow is going to head towards the right. The open is the one with no equal bar, and the closed is the one with the equal bar. Again, to the left, first of all, those were intervals that went all the numbers below 5. That's why the intervals start at -5, end in 5. These ones start at 5 and go up to infinity. So again, open, not included 5, parenthesis, closed, 5 is included, bracket. So we're going to want to pay attention to these things because every time I answer one of these questions in this section, I'm going to want to answer in an inequality, graph it, and give the interval notation. Okay. So these are inequalities right now, so I want to practice writing the interval notation and the graph for these already solved inequalities. So for the first one, x is greater than -3. So I'm going to just do my graph first. You don't have to do a lot of detail on your graph, like your number line doesn't have to have a lot of numbers on it. It really just needs to have the one you're focused on, the -3. And I need to know what type of circle to put around that -3 value. No equal bar, so open circle. And x is greater than, so I'm just going to make sure my arrow heads off to the right. Okay. So my interval is going to start at -3 and go to infinity. Infinity, if you've noticed, will always get a parenthesis no matter what, because infinity is an idea that can't actually be reached, unlike a number that can be achieved. This number, -3, will not be achieved because you don't want it to be equal to just strictly greater. So you're going to put a parenthesis around both of those. All right, let's look at the next one. I want x less than or equal to -1. So again, -1. This time gets a filled circle to signify that I'm including that value. And then less than, so all values to the left. So because it's all values to the left, I'm going over all the negatives. So I'm going to start my interval with -infinity. I'm going to end my interval with -1. I am including -1, so we'll get a bracket. I like to do my graphs first because it points the direction of the infinity. So the positive infinity, I know the infinity comes last. This one points towards -infinity. I know the -infinity is the thing that comes first. They must be in order. You can see that your right endpoint, your terminal point has to be this number in this case, and your left endpoint has to be the arrow all the way to the negative, in this case, infinity. Okay, so the next two, x is let's see, greater or equal to 2. So 2, just put a solid dot for the greater or equal to bar, and then we're going to draw this one off to the right. It's going to go from 2 to positive infinity, parenthesis always around the infinity, and bracket around the 2 because of the equal bar. And the last one, 4, open circle because there is no equal bar underneath the inequality. X less than 4 is going to head off this way. You're going to start your interval with -infinity. Let it go till 4, parenthesis around both of those because you're not including the 4. All right, so let's take a look at the next page where we're going to solve the inequalities, or at least find the pattern of what needs to happen in order to do so. So in example 2, we first are looking at the inequality 6 is less than 12. We can all agree that 6 is less than 12 is true. What we want to do is just study what happens to that inequality as we do various things, like add the same thing to both sides. So for example, you know that 6 is less than 12. What happens if you add something like 2 to both sides? that would give you the inequality 8 is less than 14. It's still true. Okay, so the inequality symbol stays the same. All right, it's still less than. All right, to make it true, to make the statement true. The next one, what if you, instead of added something to both sides, subtracted something from both sides? So if you had 6 is less than 12, is it also going to be true that if you subtract 2 from both sides, that you have a true statement? 6 minus 2 is 4, less than 10. 4 less than 10 is still true. So for this, in order for this to be true, the inequality, again, is going to stay the same. It's still less than. Okay. What if you multiply both sides by a positive number? Okay, so 6 is less than 12 was the original inequality. If I multiply both sides by a positive number like 3, multiply both sides by 3, that's going to make this 18 is less than 36. Still true. So the inequality maintains its direction. It's going to be same, still a less than. What if you divide both sides by a positive number? All right. 6 is less than 12. If I divide both sides by something, like 2, for example, since 2 goes into both of them, that would be 3 is less than 6. Still true. Okay. So the inequality, once again, stays the same. Okay, part of the reason that we're studying these, it's kind of boring when they all stay the same, but check out the next one. If I multiply both sides by a negative number, I know that 6 is less than 12. That is true. If I choose to multiply both sides by a negative 1, that gives me a negative 6 on this side, and it gives me a negative 12 on this side. Now it is no longer true that negative 6 is less than 12. Negative 12 is less than 6. So the inequality symbol must switch to keep the true statement, to keep the fact that this is true where the first one was true. It must switch to greater than. Okay. And that is because I multiplied by a negative. Notice that when I multiply or divide by a negative, the same thing is going to happen. So if I have 6 is less than 12, and I divide both sides by a negative 3 or whatever, any number I choose. 6 divided by negative 3 is negative 2. 12 divided by negative 3 is negative 4. And which one is larger? That would be the negative 2. Negative 2 is larger than negative 4. So once again, in order to maintain the truthfulness of this, we're going to have to switch the inequality. Okay. So the important thing is if I'm multiplying by a negative number or dividing by a negative number, I have to switch the inequality. Okay. And again, we just kind of studied all of these just to make sure the pattern was going to be true regardless of what I was doing. It turned out not to be true unless I switched the sign for multiplication and division by negative. So you need to remember that rule, because that rule is a rule that is goes beyond the rules of solving equations. It's a rule specifically for solving inequalities. All right. So let's take a look at a few examples. The first one, they have got 3x plus 5 is greater or equal to 14. So I solve it very much like it's an equation. I just have to make sure to watch the inequality carefully. I begin with the minus 5 from both sides. That gives me 3x greater than or equal to 14 minus 5 is 9. And then I divide by 3. That gives me x is greater than or equal to 3. Notice that I didn't change the inequality because I divided by a positive number, so no change. That inequality stayed the same. Okay. So I always need to make sure I give the inequality, the graph, and the interval. There are 3 ways to answer this. The first one is the inequality. So I've got that piece already. The next piece is the graph. And so locate where 3 is, determine what kind of circle, closed circle for the equal bar, and then greater, so head off to the right. Then the interval is going to go from 3 to infinity. Infinity always gets a parenthesis. This has got a solid circle, an equal bar, so the 3 gets a bracket. So again, just putting those little bullet points there to highlight that those 3 parts are all necessary components to the solution. It's a 3-part solution for the inequality, the graph, and the interval. All right, let's try a few more. Again, I need to get the variable by itself. So it's probably most efficient for me to subtract x from both sides so that I can get all the x's on the right. They'll give me negative 9, almost where equals, is less than or equal to 3x. Then divide by 3, we'll get negative 3 less than or equal to x. I didn't change my inequality again because the number that I divided by was positive. Divided by 3, so I don't change your inequality. Now, this says that x is greater than negative 3. Negative 3 is less than x. We like to write the x on the left-hand side just because it makes it a little bit easier to see the graph. Then the point of the inequality is the direction of the point of the graph, if you've noticed. So if I switch this around, open mouth towards x, open mouth towards x, point towards 3, you can just switch the order by switching the inequality. So x is greater or equal to negative 3, so negative 3, solid bar, arrow to the right, and negative 3 comma infinity, bracket around the negative 3, parenthesis around the infinity. So those complete my solution. Okay. 2 more. It looks like in the next one, to get x by itself, I'm going to start by subtracting an 8 from both sides. It's going to give me negative 2x is less than negative 2, and then I'm going to divide both sides by negative 2. Warning, warning, when you divide by a negative, don't forget to switch the sign. So I'm just going to draw an arrow to remind myself to switch the sign because I just divided by a negative. So I'm going to get x now, switch the sign from less than to greater than 1. Okay? Put 1 on your number line, open circle, and greater than, so off to the right. So 1 comma infinity with parentheses is going to be your solution. Another one, this one's going to have some distributing before I can begin. So I'm going to start with our 4 times our 3x is 12x, minus 4 times 5 is 20, greater than 5 times 2 is 10x, minus 5 times 3 is 15. Probably want to start by subtracting 10x from both sides to get the x's on the same side. So it's going to give me 2x minus 20 is greater than negative 15, and then adding your 20. So 2x is greater than 5, and if you divide by 2, this one gives me x is greater than 5 halves. Doesn't matter if I have a whole number or a fraction, I can graph it the same way. Just plot out where 5 halves is, open circle, greater than. So you're going to go from the interval from 5 halves to infinity. I'm going to flip the page to see what kind of variations we find in the next several of examples. Okay, example 4. We are going to write the answer in interval notation. Okay, so just again by doing the inequality, the graph, and the interval. I think these ones are just a little longer. They've got a little more distributing and more work to do for them. So let's see. I have to start with distributing. So 7x minus 7. And then minus 8x, watch your negatives on that, it's going to be plus 16, less than or equal to 5. So 7 minus 8 is going to be negative 1x, negative x, and negative 7 plus 16 is going to be a positive 9, less than or equal to 5, and subtract the 9 from both sides to get x, negative x by itself. Negative x will equal negative 4, and to get x by itself, I'm going to have to divide by negative 1. Don't forget to switch the sign. So x is greater or equal to positive 4. Okay, so the graph would look like closed circle, greater or equal to 4, and so 4 with a bracket around it, comma, infinity. Okay. And the next one, this one I'm looking at a whole bunch of fractions. So I know that the best way to deal with if an equation has a whole bunch of fractions is to find the least common denominator of all of them and multiply both sides by it. So 8, 2, 4, 2, the least common denominator is going to be 8. So I'm going to take 8 times everything. So 8 times 7/8 minus 5 halves x is greater than negative 3/4 x plus 5 halves. And again, we're going to multiply that 8 by absolutely every piece, both sides gets multiplied by the 8. Okay, here 8 goes into 8 once, that's 7 times 1 is 7, minus here 2 goes into 8 4 times, that leaves me with 4 times 5x, or minus 20x, is greater than 4 goes into 8 twice, that leaves me with 2 times negative 3, so negative 6x, and 2 goes into 8 4 times, that leaves me with 4 times 5 is plus 20. Okay, I want to get the variables all on the same side, so if I go ahead and add this 6x to both sides, that'll give me 7 minus 14x, greater than 20. And then subtract 7 from both sides. We're going to get that negative 14x by itself, greater than 13. And then divide both sides by negative 14. I just divided by a negative, so I'm going to switch the inequality. And x is going to be then less than negative 13/14. Not that pretty number, but that's what I got. Okay, so graph it. Doesn't matter where it is, just plop negative 13/14 down on a number line, open circle, and less than this time, so we head to the left. We had a lot of greater thans in a row, but this one's less than finally, and so it's going to start at negative infinity, comma, go up to 13/14, and both parentheses because there's no equal bar. All right. The next page, last page of this section, is going to deal with three-part inequalities. In a three-part inequality, you have your variable in between two numbers. So x is both greater than 2 and less than 6 in this case. What that would look like on a graph is open circle around the 2, open circle on the 6, and the filled-in area is in between them. So greater than 2, less than 6. Now you can have a couple different combinations. 2 open circles from 2 inequality bars. Again, no equal bar, so you're going to have parenthesis, parenthesis in your interval. You could have 2 equal bars, that's going to be closed circle, bracket, bracket, or you can have one of each. No equal bar, so open circle, closed circle, parentheses, bracket, or vice versa. Equal bar, no equal bar, so closed circle, closed bracket, open parenthesis. All right, so we've got 2 of these that we would like to solve. And when I solve a 3-part inequality, instead of doing the same thing to both sides, must do the same thing to all 3 sides. So if I find my x, I want to subtract 1, and make sure that I do that from all 3 sides, since there are 3 sides to this inequality instead of just the usual 2. So I'm going to have negative 5 minus 1 is negative 6, less than or equal to 3x, less than or equal to 13 minus 1, so 12. Then I'm going to divide all sides by 3. That's going to give me negative 2 less than or equal to x, less than or equal to 4. Okay. So the graph, those are both equal bar. So I'm going to graph both numbers, negative 2. These numbers absolutely have to be in order, right? So the smaller number has to be before the larger number. They both get closed circles because they both have equal bar. And then we graph in between. The interval is from negative 2 to 4. They both have equal bars, so they both have brackets. So again, that's the interval, the graph, and the inequality. Interval, graph, and inequality. The last one I'm going to want to grab my calculator for is also a triple part inequality. So I'm going to start by, it looks like subtracting 5.8 from both sides. Okay. Oops. So we're going to do minus 5.8, minus 5.8, minus 5.8, subtract from all sides. So I get 7.3 minus 5.8 is 1.5, less than negative 2.4x, less than or equal to, and then I have 13.9 minus 5.8, 8.1. Okay. Now to solve for x, I'm going to divide the negative 2.4 from both sides. All sides, I mean to say. And because I just divided by a negative, I'm going to change both inequalities. Okay. So first, 1.5 divided by negative 2.4 gives me negative 0.625. Flip it from less than to greater than, x. Flip it from less than or equal to greater than or equal to, and then we've got 8.1 divided by negative 2.4. Which gives us negative 3.375. Okay, now, just like before, when I had an inequality that was written backwards, in the case before, I think it was, that one was I had negative 3 is less than x, but I changed it to be x is greater than negative 3. This one you might not notice right away is written backwards, but it is because the smaller number is over on the right-hand side, the larger number is over on the left-hand side. So I'm going to change the order of these to say negative 3.375 is, switch the inequality, less than or equal to x, less than negative 0.625. So watch your signs. This inequality symbol flips over here. The point goes towards the negative 3.75. The open part goes toward the x. This inequality flips over here, point towards the x, open part towards the negative 6.25. I do want to rewrite it in this order because I need the numbers to be in this order to graph them, because I need the smaller value to be first on a number line. So I'm going to graph the negative 3.375 on the left. I'm going to graph the negative 0.625 on the right. The negative 3.75 gets a closed circle, equal bar, you can see I always had the equal bar. And the negative 0.625 has a open circle because that one was no equal bar, that one was the strict inequality. Okay. Then my interval is going to be negative 3.375, comma, negative 0.625 with a bracket around the negative 3.75 and a parenthesis around the negative 0.625. There are my answer. It's written 3 ways as an inequality, a graph, and an interval.